Okay, now what's going to be important to do is figure out what does the graph of an exponential function look like. Since this is a different type of function that we've discussed before, it's going to have its own set of properties and characteristics when we start looking at its graph. So let's take a look at a function like f of x is equal to 2 to the x power. Okay, now let's plug in some numbers for x and start getting an idea of the values we'll get out for y as a result. So I'm going to use numbers like -2, -1, 0, 1, and 2 for the values of x. And so if we plug -2 in, that's going to go up in the position of x. So we have something like 2 raised to the -2 power. Keep in mind that a negative exponent can be brought downstairs into the denominator as a positive exponent. So this would be something like 1 over 2 to the second power, or just 1 over 4. And 1 over 4 again as a decimal is like 0.25. And if we do this for -1, 2 to the -1 would be like 1 over 2 to the first power, or just 1/2, which would be 0.5. 2 to the 0 power. Let's see, anything to the 0 power is 1, so that's just going to be equal to 1. 2 to the first power is just 2, and 2 to the second power is 4. So now we have some different numbers to go along with the values of the function, and we can start looking at the graph based off of these values. So we'll plug in the locations here. We'll plot the points for -2, -1, 0, 1, and 2. Okay. If we plug in for -2, it's really close because it's only 0.25, so it's pretty close to 0. At -1, it's 0.5, so it's kind of in the middle. At 0, it's 1. At 1, it's 2. At 2, it's 4. And so the shape we're going to be producing as a result of having these points looks something like this. So now we can say some things about our function. Specifically, we can talk about its domain, and we can talk about its range. The domain would be all real numbers. We can go from -infinity to +infinity. The range, however, again works along the y-axis up or down. And this graph is going to keep getting closer and closer, but never quite touch the x-axis. So it's never going to go all the way to 0. So what we'll say is the range is 0, infinity. Notice that I'm using a parenthesis here because we're not going to be able to touch the 0, but just get really close to it. What this also means is the fact that we don't touch the y-axis, the x-axis I should say. Since we don't touch the x-axis, that's also what we call an asymptote, a horizontal asymptote to be precise. So these type of graphs do have a horizontal asymptote of y equal to 0. Now an alternative way of doing our exponential function is to use a fraction as the base. So what we're going to do here is do the same kind of thing we did for the other function, but we're going to use this type of base here. So -2, -1, 0, 1, and 2 for x. And I'll show you how that turns out as a result. So if we take the base 1/2, and again x is the variable, so we're going to put the x raised 1/2 to the -2 power. Well, that's going to basically flip the fraction over to make it into 2 raised to the +2 power. So that would just be equal to 4. And if we do 1/2 to the -1 power, it would be 2 to the first, or just 2. 1/2 to the 0 power would be 1. 1/2 to the first power would be still just 1/2, or 0.5. 1/2 to the to the second power would be 1 over 4, or 0.25. So really, if we compare with what we just did a second ago, the numbers are in reverse order. The bigger numbers are going to come from the negative x numbers, and the smaller numbers or values for y are going to come from the bigger values of x. So let's draw a graph and visualize what's going on here. So same numbers as before, but if I plot them in this way, from negative 2 we'll start at 4, negative 1 will be 2, 0 will be 1, 1 will be 0.5, and 2 would be 0.25. And so our graph will kind of go this direction instead. So same domain, same range, it's just going in a different direction. This is just going to fall as we go from left to right, rather than going up as we move from left to right. So here are the two functions side by side together in a graph. The f of x equals 2 to the x function rising to the right, and the f of x equals 1/2 to the x power, which is going down as we move to the right. One thing to also notice is how they both cross here at 1 on the y-axis, and that's always going to be your y-intercept, will be the point 0, 1. And notice there's no x-intercept because neither one are going to ever cross the x-axis. Now let's look at some different kinds of exponential functions and how their graphs are going to turn out, but with a few other numbers involved than what we just looked at a second ago. So for instance, here we have f of x is equal to 2 raised to the x plus 1, all minus 2. What we can do here is take the basic shape in the graph that we had before, but apply transformations to it based off of the transformations that we discussed before, which work for any graph of any function. So we have here this x plus 1, and then we have this minus 2 over here. So the plus 1, this will be one transformation here. And then this 2 over here, minus 2, will be another transformation. So our first transformation, the x plus 1, is going to cause a horizontal shift. It's going to cause a horizontal shift to the left by 1 unit. The other transformation with the minus 2 is going to be a vertical shift down by 2 units. So what we can do is take the graph of 2 to the x power and then just apply the transformations to it. So let's see how that goes. So a second ago I drew the graph of 2 to the x power. More or less we'll take this kind of the basic shape of it to look something like this. Draw it a little bit better here. Okay, something like this, let's say. That's just plain old 2 to the x power. It went through the y-axis at 0, 1. That was the y-intercept. And it also had the x-axis as its horizontal asymptote. It never touched that line. So if we want to do the transformations here, we'll just shift everything to the left 1 unit and then move it down 2 units. So how that's going to look is we can move the horizontal asymptote down 2 units. We can take this one point that we have here, move it over to the left 1 unit, oops, and then move it down 2 units. So that point will move over 1, down 2. And then we can draw the basic shape, much like we have up above, to kind of go something like this. Again, this is just a rough sketch of what happens when we have this function here, but that should show us approximately what 2 to the x plus 1 minus 2 would do after applying the transformations to it. Okay, here's another one. This one goes negative e to the x plus 1. Now, the thing to keep in mind is No matter what we have in our base, whether it be e or 2 or any number, the basic shape is going to be the same. It's just going to be a little bit steeper or not quite so steep depending on how big the number is in the base. But for this, again, we're trying to draw just a rough sketch. So let's apply the transformations and take the basic shape that we've had for an exponential function and kind of just make it look like that for the most part. So there are two transformations here. One of them is the negative in the front, and this other one, the plus 1, is going to cause another transformation to occur. So if we go back and recall what transformations happen in cases like this, the negative will cause a reflection. In fact, it'll be reflection about the x-axis. And the plus 1 is going to cause a transformation up by 1 unit. So let's start out by looking at just the e to the x function with no transformations. Basically, all I'm going to draw is the same kind of graph that we had from up above. More or less, that's going to be close to what e to the x would look like. And so I need to reflect it, which comes first, and then shift it up by 1 unit. So if we reflected about the x-axis, rather than doing this, it would go the other direction instead. So that's what the reflection will do. Flip it around the x-axis. Okay, then shift it all up by 1. So this point here can be moved up here. Also keep in mind that we'll kind of have a horizontal asymptote moving up and alongside as well. So when we're done, our graph should move down through here, kind of alongside the other graph, like so. So that's just, again, in effect, shifting it up by 1 after doing the reflection.